Okay, so welcome back. Today we're going to look at part 4 here in our series where we show you how to analyze the performance of your computer hardware, your CPU, your motherboard, and specifically we're going to be looking at the performance of your GPU, your graphics processing unit. And we showed in previous videos what software is out there to help you monitor your GPU. And we showed you GPU-Z, which allows you to monitor many different sensors on your GPU and also save that data as a CSV file. And we showed some software out there that does what you see here, which is takes that data and charts it. And we showed that there were some limitations of that software. And ultimately, we decided, hey, we can write a very simple C# Visual Studio Windows Forms application or any software you want to use to do a nicer job of charting the resulting CSV data from those sensors. And what you see here is the results of building that software application and actually measuring data that we gathered from doing a 3D render in a piece of software called Blender. And here is what we rendered. This is Blender, and this is a scene that I developed. I built all these models in 3D from scratch and textured them. And I've got two GPUs that are rendering this, a RTX 2070 Super and a GTX 1080 Ti. And what we did is we did a render, a 4K image, high resolution image. We did a render and we measured some values of the GPU, and this took about 36 minutes to render. And you can see here we've got four traces. We've got a GPU temperature, we've got a fan speed, we've got a GPU load in percent, and what's called a perf cap reason. We're going to be talking about that in this video. And we're going to be talking about how you can use this application we developed and the resulting traces that we got from GPU-Z. How can you use these traces to actually analyze the performance, in this case of your GPU? What does this all mean and how is this going to help you? And you can see we can disable some of these. And we've got in orange, we've got a fan speed, we've got a GPU temperature, we've got two axes, we've got two y-axes, one in blue to measure this GPU temperature, and one in orange to measure the fan speed here. And we can add the GPU load in red, and also this perf cap reason, which is down here on the bottom. So let's get into this and take a look at some of the values and see if we can make sense of them and maybe use them to improve the performance of our GPU. So now let's take a little bit closer look at this perf cap value that you can log from GPU-Z. Now what is perf cap? Perf cap stands for performance cap. In other words, the performance is limited, the GPU performance is limited for some particular reason. And the perf cap reason that gets plotted out is a number representing different types of reasons for capping the performance. As an example, here I've got a log that goes about 35 minutes for a long render, a Blender render, using my GTX 1080 Ti. And what I'm measuring is GPU temperature in degrees C, and that's in this blue here. Fan speed in percent, and that's this orange that you can barely see. GPU load in percent, which is this red. And the last one is perf cap reason, performance cap reason. So as I said, it's a number that represents, if it was, why the performance was capped at any point in time. And that's this dark blue down here. So what I'm going to do is I'm going to get rid of this GPU load since it's kind of annoying. And basically, we're doing the render from this point until this point. But you can see the temperature goes up to about 84 degrees C. The fan speed goes up to about 97% after 10 minutes or so. And here is the performance cap. So what I'm going to do is I'm going to get rid of it here, and I'm going to run a separate instance of this log viewer, and I'm going to zoom in on the performance cap reason. And what I've got is on the left is I've got a y-axis scale that goes in steps of 1, 0 to 16. Now the performance cap reason, as I said, is a number, and the number represents what, if any, are the reasons for the performance at that point in time being capped. So you can see it starts out at 16. We start the render, it immediately goes down to 4. And it stays at 4 for about almost 10 minutes. And then you can see it starts bouncing. It goes up to 6 and back to 4. And here it goes back to 16. And then it goes down to 2. So we've got values of 2, 4, 6, and 16. And depending on the time of the render, it's bouncing back and forth between those values. So let's keep that in mind. We've got 2, 4, 6, and 16. So let's take a look at what those mean, what those numbers mean, what they represent, and see what might be happening in our GPU at those different points in time. So here is a list of the different performance cap reason codes. And there are 1, 2, 3, 4, 5 performance cap reasons. It can be either a power limit, a thermal limit, a reliability limit, an operating limit, or a utilization limit. So power limit, which is indicated by a 1 in the output CSV file, means indicating performance is limited by total power limit. You can't exceed the power limit of the device. Thermal, or a number of 2, a performance cap reason of 2, indicates performance is limited by the temperature limit. Of course, you can't exceed the temperature limit of the device. Reliability, VREL, is a code of 4, indicating clock frequency is limited by voltage reliability. Now, these devices operate on a voltage frequency curve, and to be reliable, it has to operate on that curve in a certain range of voltage and frequency. If you go too far outside that range, you could have some problems. So there's a curve of voltage versus frequency that you have to respect. Depending on the voltage, you may not be able to support the clock frequency. Then VOP is a code of 8, means indicating performance is limited by max operating voltage, which is a hardware limit. You can't exceed the operating voltage. And then UTIL is a code of 16, utilization, indicating performance is limited by GPU utilization. And if the GPU isn't being used, it's idle. It indicates idle. So if you see a 16, it could be that the thing is just idle. It's not being used. So there's 1, 2, 4, 8, and 16. And you can imagine this is probably 5 bits in a number that are being set to indicate what the performance cap reason is. Now, we got performance cap reasons that are 2, 4, 6, and 16. So what does that mean? Well, 2 means there is a thermal limit. So apparently at some point in this render, when we hit a 2, we got into a thermal limit. And you can see towards the middle of the render, it was going into 2 quite a bit down here. So that's something we need to consider. Maybe if we can cool things down, that'll go away. So what we're going to do is we're going to do another render and see if we can get rid of this performance cap reason, which is thermal. Now, it spent a lot of time in the 4 range, which is indicating clock frequency is limited by voltage reliability. So it couldn't crank up the speed of the clock frequency because of voltage limits. So that's why it was at 4 most of the time. So that's something you could look at. Maybe there's a voltage issue. And then we had 6, and it was bouncing up to 6 quite a bit here. What is 6? 6 doesn't appear on this. Well, 6 means it's 2 of these. It's a voltage reliability and a thermal at the same time. So it's a 4 and a 2, which gives you a 6. So again, there's a thermal limit whenever you're at 6. So here and at 6. So most of the time in here, you had a thermal limit. So that's something we can look at. And then we also went up to 16. And as you can see, before we started the render, it was at 16. And here it bounced up to 16 quite a bit. So that's probably, it was idle at those points because of whatever was going on in the GPU. We can look into that. But it seems like we've got some voltage issues, some thermal issues, some cases where it's both, and then here it was idle. Now keep in mind, this may not make any difference to your actual performance, and we'll see that. What we're going to do is we're going to see if, for example, we can get rid of the thermal limit by cooling things off and see if that really, in the end, affects our render time. A lot of enthusiasts and hobbyists like to get really excited about this stuff, but at the end of the day, what's really important is, does it affect the performance over time? Is it going to do your calculations faster? If not, then it doesn't really matter. So let's take a look at seeing if we can modify and get rid of some of these performance caps and see if, in the end, if it makes any difference. Okay, so now that we've got a bit more insight into what these performance cap reasons are, let's take a closer look at the output of our render and look at these different values and see if we can make a meaningful difference in the performance of our render. Now again, this is about a 36-minute render, and I'm looking at the GTX 1080 Ti performance values. I've got two GPUs running. I'm just looking at the GTX 1080 Ti rendering a Blender scene. And let's take a look at this performance cap reasons and see if we can figure out what we might be able to modify to make this perform a little bit better. So we said that we've got down here our performance cap reasons being plotted, and they are, in our results, they are values of 2, 4, 6, and 16. 2 is a thermal limit, and you can see down here at the very bottom, we've got a bunch of times where it jumps down to 2, which means a thermal limit. 4, which it's at most of the time, indicates a voltage versus frequency curve limit we'll talk about later. And then 6, which is above the 4, means both. It means a thermal plus a voltage versus frequency limit. And then 16 is the highest up here. So it might be the easiest if we first look at the thermal performance, where it happens quite a bit here. You can see it's going down to 2 and up to 6, which means there's a lot of thermal limitations going on. And especially here in the last 2/3 of the render, a lot of this is thermal and thermal plus the voltage versus frequency. So it might be easiest to just say, hey, maybe we can fix the thermal problems, and instead of having a 36-minute render, maybe we can get it down to 2 minutes. Wouldn't that be cool? So let's see if we can figure out some way to improve the thermal performance and maybe help the performance of our render. So what I did is I figured, well, one way to cool off the computer and the GPUs during a render is to remove the side panel, to basically open up the computer box and let some air in and see if that makes any difference. So what I'm going to do is I'm going to fire up another instance of this log viewer application we're building, and I'm going to look at the results, exact same render, exact same GPUs. The only difference is I removed the side panel. And here are the results when I remove the side panel. Now you can see that the curves look almost identical. The only difference here is that with the side panel on, I ran it after it finished rendering. I ran it a couple minutes longer than this one, but if you align them, you can see they both look about the same. So up here we've got all these 2, 4, 6, and 16 performance cap values. If you look down here, the performance cap is basically one value the entire time, and that's the 4 value, which means voltage versus frequency. So it looks like we've gotten rid of all of the thermal performance cap limits throughout this entire render. So you might think, well, cool, we cooled everything down, so this thing performed a lot better, right? Well, it turns out, if you look here, if you line these up, it took exactly the same amount of time, 36 minutes to render, even though we fixed the performance cap limits on the thermal. So yeah, you can go through and you can do stuff like that, but it may at the end of the day make no difference. So let's see what else we can get from this in terms of learning how this thing responds. So what I'm going to do is I've got in red here, it's kind of messy, we've got the GPU load in %, and you can see around the middle of the render, the load goes from almost 100%, and it drops down to very low values, almost zero. So something's going on here. Maybe there's some sort of limit. Maybe our reliability limit is causing this to shut down a bit. We can look at that later. But I'm going to get rid of, in both of these, I'm going to get rid of the GPU load percent and see what else we have. So you can see we've got in orange or red, we've got the fan speed in percent, and that's measured on the right axis. And in blue, we've got the GPU temperature in degrees C, and that's measured on the left axis. And you can see here that there's quite a bit of difference. If you look at the fan speed, here it went up to a maximum of almost 100%. The fans were fully running, 97% here at maximum. If you go down here without the side panel on, with presumably a cooler case, the maximum fan speed was only 77%. So taking off the side panel made quite a bit of difference. The fans didn't have to go nearly as fast. It was like a 20% difference. And if you look here in blue, the GPU temperature, here with the side panel on, the maximum was about 84 degrees centigrade. And here without the side panel, the maximum was only 77. So that's about 7 degrees cooler without the side panel. But again, with all of that, a lot cooler running, 7 degrees cooler maximum, it still took exactly 36 minutes to render. So this is nice in that you can see the interaction between fans and GPU temperature and performance cap reasons. And you can learn a lot here. You can go through and do different renders or monitor different stuff and see what the result is. You can look at GPU megahertz values. You can look at all kinds of things. So this gives you just an idea of some of the kind of stuff you can look at to learn what's going on. And again, it's really nice to have multiple axes where you can measure two different things. So that's about it for this one. Hopefully this will help you get started on learning how to analyze performance of your hardware. If you like any of these videos, I encourage you to hit the like button, subscribe, hit the bell notifications. But most of all, please let others know that we're here so we get some views. Really appreciate it. Otherwise, take care. Have a really good day. Thanks.